just look at these names. Do we really have to draw the triangles to come up with the congruent parts, the corresponding parts? Pick me a segment, a side in this triangle. QR. Please remember, using your symbols, what's it match up to? Does everybody agree with that? That's one pair. Give me another one. RP. Segment RP is congruent to GK. And the third pair, QP. If you want to draw them, if it helps you to draw them, am I going to make fun of you? FK. If your name's not Kylie J, am I going to make fun of you? You think I'd make fun of you too, Hannah? Everybody makes fun of Hannah.
No.
So it's all three pairs of sides or segments that match up, the angles. And I even said here, you can just use one letter to make it easier. Name me an angle in this first one.
Q.
And what's angle Q match up to in the second one? Ignore that. Give me another pair.
R.
Angle R, and it matches up to
G.
And then the last pair, oops, yeah, I thought I forgot my symbol. Angle what?
E.
P matches up to,
K.
so we know all those things are congruent. So if we happen to draw the two triangles, we could say, okay, we know that that's congruent to that, and so on, so on, so on, going from there. What we're going to do, we're going to start proving triangles are congruent today. The rest of this chapter, that's what it's about. A lot of two-column proofs. Got to pay attention. Not as hard as the other two-column proofs that we did, I don't think. But if you're not paying attention, you know how much you love two-column proofs. Page 330, questions. Problems you want to see worked off page 330.
Number 11.
Number 11. I'm not sure what they ask us to find, but we'll just find everything that we can find. What do you know about these two sides in this triangle? They're congruent. So we had a theorem last time that said if these two sides are congruent, what do we know about the angles across from them? Draw in these arrows. Help yourself out, all right? I know Sean thinks that I do it just because I like drawing arrows. That's why I became a geometry teacher, so I could draw arrows all over the place. Draw them in, they help. So these two angles have to be congruent. If this angle is 60 degrees, these two have to be congruent. What do we know about all three angles in a triangle? They have to add up to 180. So if I do 180 minus 60, what's that give me? 120. How can I find these two angles?
Divide 120 by 2.
Take 120 divided by 2, what's that give us? So that angle's 60 degrees. That angle's 60 degrees. Sorry, you can't hardly read that. What's that tell us about all three angles?
They're all congruent.
They're all congruent. And if they're all congruent, what's that tell us about all three sides? So if this one's 7, that one's 7, what's this one got to be?
7.
Did we find everything in there? I'm not sure what they asked you to find, but did we find?
Yeah.
We had to find, since we found everything, we had to find the answers that they wanted. Next question. 15. 15, they give you a yield sign. Anybody know what shape a yield sign is? It's a triangle, that's true. A special kind of triangle? I guess we'll find out here in a minute. 4x plus 2, that angle's 60 degrees. This side 3x plus 9, is that right? And what is this angle? I can't see it. 4y. We know these two sides are congruent, so if those two sides are congruent, what has to be true about the angles across from them? They have to be congruent. Notice I drew the arrows in again. This side and this side are the same, then the angles across from them have to be the same. It works also backwards from that if the angles are the same. I thought it was the same over here, but it's not. If the angles are the same, then the sides across from them have to be the same. So what do we know about 4y then? It's got to be 60. So you got your calculators out so we can figure this out. What do we do to solve that? What's y equal? And I think on this problem, all they asked us to do was solve for x and y, right?
Yeah.
Now, we know y is 15, but what do we know about this whole angle right here?
It's
60 degrees. So I could write 60 degrees in there. That angle's 60 degrees, this angle's 60 degrees. What's this angle? 60 degrees. So what do I know about all three of these sides in this triangle? So I can mark that one that way. Now can I set up an equation to solve for x?
Yeah.
These two have to be the same, so what equation could I write?
3x plus 2 equals 3x plus 9.
Does everybody see that? Since this is ends up being an equilateral triangle, these two sides have to be the same, so we just set up that equation. X equals 7. Subtract 3x. Subtract 3x, that leaves us x plus 2 equals 9. Those cancel out. Subtract 2. X equals 7. Next question. Eight. And put the letters on the corners or the vertices this time. See if we can get away without doing it. These two sides are congruent. What do I know about those two angles?
They're congruent.
So let's mark them congruent. This sort of looks like that first one we did. If we know that this angle's 60, how can we find these two? Subtract that from 180, what's that give us? And then how are we going to find each one? So that means this angle's 60 degrees, this angle's 60 degrees. So what kind of triangle do we have here? It's an equilateral, it's also an equiangular, right? So if this side and this side are congruent, we also know that what is true about this third side? It's congruent, so all three of those are congruent. What equation can we set up?
3x plus 8
That has to equal that, right? 3x plus 8 has to equal 4x minus 4. How do we solve that? Minus 3x on both sides, good. 8 equals 1x minus 4, then what?
Plus
Add the 4.
Add 4 to both sides. X equals 12. What'd they ask us to find?
The value of x.
Just the value of x. So that's our answer. Now, some of them, when you're doing this, did they ask you to find these two angles? A lot of times, I said this last time, a lot of times you're going to have to find stuff, even though they didn't ask you to find it to lead you to what you're trying to get to. Too many times, students in geometry think you're back in algebra and, oh, if I find x, I'm done. And you just work to find x, and that's it. A lot of times now you're going to be finding all kinds of stuff before you get to the answer that you actually need, or that answer that you actually want. Next question. Six. Should put a graph on here. Help me out so I don't have to keep trying to look back at the book. Let's find the coordinates.
That's supposed to be 52 degrees.
Yeah, my book's different than yours. We figured that out the other day in intervention.
What says 56? I says 56.
Yours says 56. See, some of the books are different. I don't know why. We'll go with 52. It won't make that much difference. They must have had a different printing. Split up the books. What is this? This is S, R, and T. S, R, T. Help me out. What's the coordinates of point S?
Over 0, 1.
What's the coordinates of R?
Over 5, up 5. No, over 4, up 5.
So what's that telling me?
Negative 4, 5.
Negative 4 or 5. Everybody agree with that? What's for T? Negative 4, negative 3?
Oh, I know. Just 3. Wait. You actually, no, you're not negative 3.
Is that right?
Yeah.
And they wanted us to find the lengths of the 3 sides and the other 2 angles, since we already know one of the angles. Which side's the easiest side to find?
RT.
How can you find the length of segment RT over here? Just count. In your books there, just count it for me.
8.
So it's going up 8, is that right? Yes, no, maybe, everybody agree with that? How are we gonna find the length of segment? Let's do RS next. We gotta use what? That's an X, that's a Y, that's an X, that's a Y. Let's go ahead and put that on there too. That's an X, that's a Y. Have your calculators out so you can help me here. What's our X's for RS? And I'm gonna turn them around and go 2, negative 4. Is that all right?
Yeah, so you can make
So you can do the plus plus or whatever your middle school teacher said. What's our Y's this time?
5 and
5 minus 1. Somebody plug that into the calculator for us. Just plug in this part underneath here.
52.
52?
Yeah.
Anybody else get that? Yes, no, maybe? What's the square root of 52?
7.2.
So how long is that segment? What's the other segment we gotta find the length of?
T.
ST.
TS, ST, whichever way you wanna say it. What's our X's for T and S?
-4 and 2.
Negative 4 and 2. Again, I'm gonna turn them around. Is that all right? So we do the plus plus there. What's our Y's?
1 and -3.
1 minus a -3. Do the plus plus again. And some of you, it'd be helpful if you don't like punching all this into your calculator, which apparently you don't, because Mr. Lee's sitting over there with his arms crossed and his calculator's getting lonely, laying there on his desk. Then just write it down and do a little math. 2 plus 4 was 6, right? 5 minus 1 is 4. So we got 6 squared, we got 4 squared. Maybe stop there. What's 2 plus 4 down here?
6.
6. So we got 6 squared there. What's 1 plus 3 here? Got 4 squared. Anybody notice anything? It's the exact same thing. So what answer should we get for this one? 7.2. What's that tell us about the lengths of these two sides right here? They're congruent. They're congruent. What's true about those two angles? They got to be congruent. So what's the measure of angle R? 52. If your book said 56, then
It's 56.
it's 56 degrees. So we know this is 52. That one's 52. How can we find angle S up here?
180 minus 140.
Do 180 minus
Well,
50,
104.
52 plus 52, right? Which is 104, is that right?
Yeah.
What's that give us?
76.
Again, that would change, if your answer, or if your book said 56 degrees, it would change your answer just a little bit, but if we had this problem right here, and it's got a number 16 on it, I'm going to take that off, and we were going to prove these two triangles congruent. First of all, how many triangles are in this picture?
3.
Two.
I heard the answer once. But,
6. 2. 4.
there's 3 of them. There's 3 of them, all right? This time there's only 3. There's this small one right here in the middle, and then the 2 big ones, right? Which 2 are we going to be trying to prove congruent, do you think? Are we going to prove this small one's congruent to anything? No, it has to be the 2 big ones, right? So the 2 big ones sort of lay like this. Can everybody sort of see that? They lay like that where they cross over each other a little bit there. And we want to separate them, and that's what you need to be able to do. You need to be able to separate them, and we're going to prove that they're congruent. So if I separate this triangle, what's this letter right here?
B.
What's this letter? What's this letter?
G.
If I separate the other triangle, this one over here, what's this letter up here?
C.
Can't hardly see it, sorry. What's this letter? And what's this letter? And we got to be able to make sure that we're matching them up. A in this first triangle matches up to what in that other triangle?
D.
Matches up to D, doesn't it? What has to happen? What do you got to do to it? You got to sort of flip it over. You got to be able to do all this with what we're doing today. Now, if we were going to prove these 2 triangles congruent the way that we've been doing it so far this chapter, you got to prove all 6 parts in this triangle match up to all 6 parts in that triangle. And this is what happens if you have to do that. Just relax for a second and watch. This is my 2-column proof. So far, nothing real hard. Now Michael's getting a little annoyed. gotta prove all 6 parts of one triangle congruent to all 6 parts in the second triangle. So these 2 column proofs that we're getting ready to do, you guys are gonna love them, aren't you?
Oh, yeah.
The ones that we did in the past had what, maybe
6.
3, 4, 5, 6 steps at the most. Now we got what?
11, 12, 13.
A whole bunch. So you're probably not going to enjoy this too much if we had to prove all 6 parts in this triangle congruent to all 6 parts in that triangle. But with what we're going to cover today, if you listen and follow along, what we're going to cover is we're going to shorten that way up. This proof right here would take actually about 5 steps with what we're going to learn today. So the notes, did everybody grab the notes from up here? Proving triangles congruent. Make sure these notes get into your binder where they belong. There's easier ways to prove 2 triangles congruent. So instead of having to prove all 6 parts of one triangle are congruent to all 6 parts of another triangle, we can shorten it up. And these are the 2 ways that we're going to learn today. SSS method and the SAS method. The first one, SSS. Anybody have a guess what SSS stands for? No? Pair of sides, pair of sides, pair of sides. So what they're saying there, before you start writing all this, what they're saying is if I can prove that these 2 sides are congruent, and I can prove that these 2 sides are congruent, and I can prove that these 2 sides are congruent, then guess what we know about these 2 triangles? They have to be congruent. All the other parts have to match up. So instead of proving all 6 parts, we only got to prove 3 parts, or 3 pairs of parts. So this is just side, side, side. Usually, I put pair of sides in here because it seems to confuse people. But in the past, I've always just had side, side, side. So you prove 1 pair of sides, another pair of sides, 3rd pair of sides, and then we know that the 2 triangles are congruent. When we prove these 2 triangles are congruent, again, we still got to make sure that we match them up. Somebody name this first triangle for me.
GWP.
GWP, I heard. So GWP. Does it make any difference how you name the first triangle?
No.
Makes no difference whatsoever. All that matters is that you match the second triangle up with that. Looking here. When I'm looking at G, what I look at is angle G right there is between how many marks and how many marks?
1,
1 and 3.
so it's H.
What over here is between 1 and 3?
H.
So G has to match up to
H.
H. W is between what? 2 and 3. What over here is between 2 and 3?
And that leaves M.
And that leaves M that has to match up with the P. Did you have to name it this way?
No.
several different ways you could have named it, as long as you match the two up correctly. All right? Make sure you're using your triangle symbol out in front. Just like with the angle symbols, you got to make sure you're using your symbols on both of them. What's that tell me about angle G? What's something you know about angle G now? It's the same as angle H. So if I told you angle P over here was 26 degrees, what could you tell me in the other triangle? That means angle M over here has to be 26 degrees. All right? We use side, side, side to prove the two triangles are congruent. So if these two triangles are congruent, then what do I know about these two angles? They got to be congruent. What do I know about these two angles? They got to be congruent. What do I know about these two angles? They got to be congruent. So instead of proving all 6 parts or all 6 pairs of parts, some mathematician a long time ago said, hey, if we just prove all 3 pairs of sides, then the triangles have to be congruent. So it shortened it down, like made it half as long. What do you think SAS stands for then on the next?
Sides, angles.
Pair of sides, pair of angles, pair of sides. Fill in what you need to fill in there. Now, SAS is a little harder. And we'll get to that here in a second once you fill in some of the stuff. So it's pair of sides, pair of angles, pair of sides. But this pair of angles right here, it's got to be the included pair of angles. And all included means is the one that's between the 2 pairs of sides. It's included. It's in with the 2 pairs of sides. So if I'm looking at this, if I'm looking at these 2 sides right here, which angle sort of falls between those 2 sides? Does everybody see that? The 2 sides come together to make the angle. It's got to be that angle. And then this other one, which angle does it have to be? It's got to be those 2 angles. So if I gave you this picture, would that work? That wouldn't be side, angle, side, would it? It's got to go in some kind of order. Watch. Side, angle, side. Side, angle, side. Does this go in that order? This goes what? Side, side, angle. That doesn't work. So it has to be in a certain order, otherwise it won't work. How come side, side, side didn't have to be in a certain order?
Because it's all the sides.
It's all the sides. Is there any way to get it out of order? No, you go side, 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 or you could go side, side, side. There's no way to get it out of order. You can't screw it up. This one you can. Got to be that included angle. It's got to be the angle between the 2 sides that you're dealing with. Somebody name this first triangle for me. Say it again. N-A-T. What's the N match up to in the other triangle? Everybody agree with that? What's the A match up to? And what's the T match up to? Got to make sure that you match them up correctly. Again, is this the only way to name these two triangles?
No.
Somebody name the first triangle a different way for me. T-A-N. And then what's it match up to? So Ebersole's got to know that, hey, Michael could have this answer, Keith could have this answer. Is either one of them wrong? No, they're both correct. And there's other ways also. Again, main thing with this, side, angle, side, got to be the included angle. So this doesn't work. What we had up here, what I did up here doesn't work. So you got to be able to pick up on that. A stable figure. Not sure, was there anything to fill in on this?
Yeah, I mean, not really.
No.
It's just pictures.
Yeah,
Got
it's
this.
just pictures.
I got the shapes there.
Yeah.
Did I not put the shapes on my, didn't put the shapes on my PowerPoint? What I have, a pentagon?
Yeah, and then a rectangle.
A hexagon. What makes something a stable figure? And we talked a little bit about this earlier this year, but not a whole lot. If I went home and I went out to my wood shop and I just built this shape, and I tried to stand on this edge right here, what's going to happen to it?
It'll collapse.
It's going to collapse. All right? To make something stable, we want all the diagonals to be drawn in so that all the small shapes inside this are triangles. That's going to make it a stable figure. So in other words, if I took this shape and I drew in this, and I drew in this, what are these three small shapes in here? And now if I stand on this edge right here, guess what doesn't happen? It doesn't collapse. It would be stable. All right? So when we're talking about a stable figure, that's what we're talking about. You draw in diagonals from one vertex to another vertex until all you have is triangles in there. Now, we don't want to draw a bunch of extra ones if we don't have to, because that just takes more wood. We don't want to have to go through all that. What would I have to draw in this rectangle?
An X.
Do I have to draw an X?
Oh, no, you can
Could just do one, and that would make this stable. So I should be able to stand on top of this, and it should hold up. Now sometimes if we're building something, we might draw in this other one just to make it even more stable, more sturdy. The last one down here, you pick a vertex, I don't care, it doesn't matter which vertex you pick, but we just want to draw in till all we have inside here are triangles. That makes that a stable figure. As we're doing these proofs, the book or other any tests or any papers I hand out might say do a flow proof or do a paragraph proof. Unless I explicitly tell you to do one of those proofs, don't do it. So if I forget on one of the papers and it says do a flow proof, and I don't explicitly tell you to do it, do a 2-column proof. Everything that we're doing is 2-column proofs. Does everybody understand that?
Yes.
So no flow proofs, no paragraph proofs. We're not doing any of those. Everything that we're going to do is going to be a 2-column proof.
Thank God.
Is this on the back side? So as we do these, we'll do these 2 examples together, then there's a couple other examples up here that you guys are gonna do?
And
First thing, look at the given information. We'll figure out what triangles we're trying to prove congruent. How many triangles in this picture?
2.
2. So it's gotta be those 2 triangles, doesn't it? This one, we're trying to prove it congruent to that one. If it helps you, separate the 2 triangles. Draw one of them over here, draw one of them over here. Separate them off and look at them that way. That's totally up to you. A lot of times it will be helpful. Sometimes, like on this one, I don't know that it is so helpful because you can see both of them pretty plainly, right? Mark the stuff you know. Segment KL. Where is segment KL? Left or right triangle?
Right. The left.
Left triangle. Bottom, top, side, what?
Side.
Right here? And what's it congruent to? Mark that on your picture. That's a pair of what in our 2 triangles? Pair of sides. Pair of sides. Is that enough to say the 2 triangles are congruent?
No.
How many parts do we need to say the 2 triangles are congruent? 3. Side, 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 or side, angle, side. So we got 1 pair of sides. That means we're a third of the way there. What next? Where's KM?
At the bottom.
Bottom of the left triangle, correct? How am I going to mark it?
2 lines.
Put 2 little marks on it. Do that on your paper.
Looks like a
Where's NM?
On the right bottom.
That's another pair of what?
Sorry.
And then the middle line can
Let's
just.
slow down, slow down. Is that enough to say that the 2 triangles are congruent?
No.
No. The bad thing is now we're out of given information, aren't we? So we got to come up with something on our own. That's where Cooper has trouble because it's got to come from where? His brain. He's got that hat squeezing his brain. His brain can't take it. Now go ahead, Kendall.
The middle line can get 3 lines, because it's 2 lines on top of each other.
What do we know about segment LM in this triangle and segment LM in that triangle? It's the exact same segment, isn't it? So this is congruent to itself. Anything equals itself. You remember the last few days me saying we're going to use anything equals itself over and over and over again? You got to be able to pick that out. That's got to be one of the easy things as we go through and do these 2-column proofs. That's another pair of what?
Sides.
Is that enough to say the 2 triangles are congruent?
Yes.
So now we should be able to prove that these 2 triangles are congruent. What's our first statement going to be? How do we know that? These proofs ought to be a whole lot easier than the other proofs. Quit coloring in my triangles and write this stuff down, Miss Johnston. Make me throw something at you. These proofs ought to be a whole lot easier than the other proofs because you got some kind of pattern to go by. Either it's got to use side, 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 or side, angle, side. So you're knowing, hey, I got to either do this or I got to do this as I'm going down through and doing this proof. When I'm doing these, out here next in front of the statements, if that's a pair of sides, I put a little s out there just to help me remember, hey, that's 1 pair of sides. Is that enough to say the 2 triangles are congruent?
No.
Where do I go to next?
Okay. Segment KM is congruent to segment N.
How do we know that?
So it's given.
That was given to us also. And that was another pair of sides. So now I got a pair of sides, another pair of sides. Is that enough?
No.
No, that's 2 parts. I need 3, right? But that's all the given information. So where do I go to now? Now you gotta come up with something on your own. What did we come up with on our own? Segment LM is congruent to segment LM, and that's what you write. You write those three words right here. Anything equals itself. Anything equals itself. That's another pair of sides in the two triangles. Do we have enough now to say that the two triangles are congruent? Pair of sides, pair of sides, pair of sides. If we have enough, these two things are always going to be a reason. They're always going to be in the reason column, but they're only going to match up. They match up with triangles. Your statement's got to be that the two triangles are congruent. That's the only thing that these can do. So they only go with triangles. So if you put LM is congruent to LM and then put side, side, side over here, it's wrong. Does that make sense? Got to go with triangles. They didn't name the two triangles for us. Triangle KLM, they named one of them. What's that match up to? What's K match up to? N. L matches up to, and M matches up to. That's going to be our fourth statement here. Triangle KLM is congruent to triangle NLM. And our reason is just going to be SSS. Anytime it's triangles here, it must be side, 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 or side angle side as the reason. That's the only thing that can fall in there. Does that make sense? These little abbreviations can be used for nothing else except for this.
Can they have both?
It could. Why would you want to? That just means you'd have to do more work, right? So if you can prove it one way, why do it both ways? I mean, I guess Clifton, we could take a vote as a class. If Clifton wants, can he do it both ways? Should we make him do it both ways and
No, please
make him do it longer?
Why don't we just take it?
Next one. You can't. 2:30. How many triangles in this picture? Two. First piece of given information. Segment BC is congruent to segment DA. So come over here to the picture. Segment BC is congruent to segment DA. That's a pair of sides, right? Is that enough to say the two triangles are congruent?
No.
And then
What's the next piece of given information tell us?
BC's
This time it says they're parallel. Uh-oh. If those two are parallel, does that help us to know that they're congruent to each other or anything? No, but parallel tells us that we might have other things. As soon as you see that you have parallel stuff, what are some special pairs of angles that you should probably be looking for? Parallel. What do we use parallel over and over and over again? Wow, we're starting to, you got it. Not opposite, alternate interior angles. Alternate interior angles. If I have this line and I have this line, what could we use as our transversal?
Right down to it.
What's formed when we do that? And if a Z is formed, what do we know about these two angles? They're congruent to each other. Somebody name this top angle for me. Angle BCA, does everybody agree with that? BCA, everybody agree with that? Somebody name this bottom angle for me. CAD. Notice over here, this is like me just writing out some notes for myself. If I'm writing an English paper, I'm just writing out some notes saying, what am I trying to prove here? Or how am I proving this? How did I know that those two angles were congruent? Because they were what?
Alternate.
And we're going to have to put that in our proof somewhere. So that's a pair of angles, isn't it?
Yeah.
We got a pair of sides, we got a pair of angles. Is that enough to say the two triangles are congruent? But we're out of given information.
That's okay.
So we need something else.
No.
Remember, if we're going to use, with all we have right now, we got side, 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 or we have side, angle, side. And we're probably going to use side, side, side this time.
No.
No, because we got a pair of angles stuck in there. With side, angle, side, the pair of angles has to be the included angle, so it has to be between the two sides. So what other side would make that the included angle? AC. Well, what do we know about AC, segment AC in this top triangle, and what's it match up to in the other triangle?
It's equal itself.
It equals itself. So segment AC is congruent to segment AC because anything equals itself, right? That's another pair of sides. Is that enough to say the two triangles are congruent?
Yeah.
So should we be able to go through and do this?
Probably not.
Statements, reasons. What's our first statement going to be?
BC is congruent to segment DA.
Segment BC is congruent to segment DA.
It was given.
That was given to us. And I didn't hardly leave myself enough room, but that's a pair of sides, right? Can everybody see that little S? Pair of sides. Is that enough to say that the two triangles are congruent?
No.
Number two,
Segment BC is parallel to segment DA. That's given.
that was given to us. Did I put another little S out here beside the two? No, because we weren't saying that those two were congruent, we're just saying that they are parallel. Soon as Hannah sees that you have parallel lines, Hannah, look for the Z. Soon as you see that you have parallel lines, look for alternate interior angles. Did we have alternate interior angles this time? What were they? Angle BCA, oops, BCA, and it was congruent to angle, say it again, CAD. Sorry, you can't hardly read that, that's angle BCA. Our reason, if, and watch, because every time you see parallel lines, guess what one of your reasons is going to be? The one that we're getting ready to write right now. If parallel lines, then what do we know about alternate interior angles? What had to be true about alternate interior angles? They're congruent. If the lines are parallel, then alternate interior angles have to be congruent. That was a pair of angles, so I put a little A out here beside it. Can't hardly see it. Got a pair of sides, got a pair of angles. Is that enough to say the two triangles are congruent? We got a pair of sides, pair of angles. We still need what?
Sorry.
Another pair of sides.
AC is congruent to AC.
Segment AC is congruent to segment AC. Anything equals itself.
That's a side.
As a pair of sides. So what can we put out here beside the 4? Little s. So now we got a pair of sides, we got a pair of angles, we got a pair of sides. Is that enough?
Yeah.
Yeah. So as soon as we have enough, we can jump to the two triangles, what we're trying to prove. Before I even write down the 2 triangles, what's our reason going to be this time?
SAS.
Side angle, side. They named the 2 triangles for us. Do we have to match up the triangles? Hopefully they did it for us, right?
Yeah.
It's right here. We just write that down. Triangle ABC is congruent to triangle CDA. Again, the only place that this reason can be in a 2-column proof is matched up to 2 triangles being congruent. That's the only time it can go as a reason. Nothing else. How many points would this be worth on a test?
10.
Should everybody get this point?
Yes.
Should everybody get this point? This point? This point? Maybe you don't remember anything about alternate interior angles. I hope not. It worries me the way you guys took you a minute to get it today, but I hope that's just Monday. All right? So maybe you missed this point and you missed this point. Should anybody miss this?
No.
As soon as you see a picture and it's got 2 triangles in it and they look like this, or they look like this, or they look like this, should you right away think, hey, they share that side? And somewhere in our 2-column proof, we're going to use anything equals itself. Every single time. So you should get those 2 points. Should anybody miss this point?
No.
It's right here. They gave you the 2 triangles. All you got to do is write it in there. You might miss this one. As of right now, you know that if you put 2 triangles down here, your reason has to be what? Either side angle side or what?
SSS.
It's got to be one of those 2. Those are the only things that can be reasons for 2 triangles. This time it's not that one. So now you actually have a 50-50 chance of guessing and getting that reason correct. So maybe you get it right also. You're a good guesser. 7 out of 10, or 8 out of 10, sorry, what percentage is that? 80%. That's the assignment. We got about 20 minutes left. That assignment's on your paper there, right? So we're going to skip to this. You're going to do these problems. Probably ought to make Hannah come to the board and do them all for us, right?
I'll do it.
Hannah, you said yeah?
No. Are we gonna turn this in or something? Like, am I gonna put it on this piece of paper?
No, you don't have to.
Okay.
So we're going to do these together. Somebody go up there and start marking stuff for us.
Yeah.
No. I'm not a teacher.
When you're doing these 2-column proofs,
Stop.
you've got to go through and mark everything in the picture before you actually start trying to do the proof. If you don't, you're going to get lost. I know everybody's paying attention to this, right? If you're not paying attention, if I see one person not really focused and paying attention up at the board, we'll stop, and there's 3 of these problems on there, and you'll do them on your paper as a quiz grade. We don't want that, do we? So, notice Kendall marked segment SP is congruent to segment TP. That's a pair of what in our two triangles?
Sides.
Pair of sides. Is that enough to say the two triangles are congruent?
No.
No. Then it says segment PQ bisects angle SPT. What's it mean if we're bisecting an angle? Splitting it into two congruent angles, right? Since we're bisecting an angle. So what two angles have to be congruent? Go ahead, mark them.
Should I do two since I did?
No, that's
It
fine.
doesn't matter.
So what two angles did she just mark there?
Angle P's.
Don't, do we want to name them angle P?
Angle SPQ. SPQ. QPT.
Angle SPQ is congruent to angle QPT. Does everybody see that? So that's a pair of angles. So far we have a pair of sides and we have a pair of angles. Is that enough to say the two triangles are congruent?
No.
But that's all the given information.
No.
Are we done?
No.
Is there anything we can come up with on our own?
PQ equals so.
PQ is congruent to PQ, right? They share that side. Does everybody see that? Boy, have we used that a bunch today? Every single problem, I think, hasn't it been? Is that enough to say the two triangles are congruent?
Yeah.
By what?
Side.
Side, angle, side. Now make sure, is the angle between the two sides? Is it the included angle?
Yeah.
Yeah. It's between the two sides. So now, help her out and tell her what's she gonna drag over there for statement number one.
SP is congruent to TP. You gotta like,
Do I
you have to like click
hit
it.
the bottom button?
You have to hit it, but there you go. And then
Is that not dragging?
No, it's just color.
My fault.
It says-
Give me a sec.
Fix that.
I forgot.
Oh, I was supposed to click it. Yeah. I didn't type it. Oh. I thought you can see my shadow on this computer.
All right. All right now.
No. Oh no. This again.
Remember, you got to grab it like at one of the edges.
Yeah.
Not one of the corners, just one of the edges.
give it.
Does everybody agree with that?
Yeah.
How'd she know that?
Just give it.
Given to you?
It says.
That's a pair of sides, right? Now, we can't really write it up there because our pen won't work now, but
That's also good. Great.
does everybody agree with that?
Okay.
Now, once you knew that that angle was being bisected, what'd you guys tell me? She marked it up there.
SP and PT are no.
If that angle is being bisected, what's happening to it? Split into two congruent
Angles.
angles. What were those two congruent angles?
P. That's the angle.
Okay.
So we know that those two angles are congruent. How did we know that those two angles are congruent? If an angle is bisected, then what's happening to it?
Splits into two congruent segments.
Again, these reasons, are you ever going to use any of these reasons again? Over and over and over again. You're using the same reasons over and over and over again. Everybody agree with all that?
Yeah, I think it is. There's
Two more.
slides. Yeah.
Somebody else jump up there.
Mikey.
No.
You just want me to stay?
Yeah, click it. I don't want to do
I'll
it.
just stay.
I like
You see where it says 14? Click on that.
Okay. Well,
Yeah, it's hard to read it.
AB is congruent to, is that a D?
CD.
CD. AB is congruent to CD. So
Use
put
the
that-
other pen.
Like the marker?
Yeah. Because that pen won't work when. So we got a pair of sides, right? What's the next thing? They're also parallel. Didn't we just get done doing this?
Yeah.
As soon as you see those are parallel, what should you look for?
Angles. The Z.
Alternate interior angles. So what do we know about those two angles that she just traced there? They're congruent, so that angle is congruent to that angle. So we got a pair of sides, we got a pair of angles. Is that enough?
Other side.
And we need another pair of sides. What is that other pair of sides?
AC.
Segment AC is equal to or congruent to segment AC. Is that enough?
Yes.
Yeah, by side angle side.
We got
So
sides.
let's start dragging stuff.
It's
We
this,
just
right?
got done doing this exact same one. Well, it wasn't exact same, the picture is a little different. Does everybody agree with that?
Yeah.
Pair of sides, right?
Yeah.
No.
As soon as Kylie J stop for one second, Kendall.
Yeah.
As soon as Kylie J sees that she's got parallel lines, what should you think of next? Right away, parallel lines. Alternate interior angles, the Z, all right? Everybody got that?
Yeah.
Sean, you see those parallel lines, alternate interior angles, every single time.
I think so, right?
Is that correct?
Because,
Angle BAC, is that right?
Yeah.
And angle DCA. If lines are parallel, alternate interior angles are congruent.
AC.
So, we got a pair of sides, we got a pair of angles, right? We need another pair of
Sides.
sides. And that's what Clifton's trying to tell you that I stopped him.
that's anything versus stuff.
How'd you know segment AC equaled segment AC?
Because anything equals
It's the exact same segment, anything equals itself.
Yeah.
size.
Yeah.
Okay.
Oh, I see. Z.
Segment LM is congruent to segment JK. We mark them. Oh, one other thing I will say. If we're doing these problems and Michael's asking me for help and I come over to his desk and I start to help him and he's got the two columns drawn and the given information written in there and he's not marked anything on his picture or anything, I walk away from Michael. You got to mark stuff in your picture and think it through before you start trying to do the actual two-column proof. Does everybody understand that? This is just like English class, and I'm hoping your English teachers do the same thing. If they tell you to write a outline, and all you're doing is writing your final draft, and they walk over to you to try to help you, and they say, "Where's your outline?" And Sean says, "Oh, I didn't do an outline." If I'm the English teacher, I walk away and I say, either do an outline or I'm not helping you. You've got to do the outline first. Does everybody understand that? Sean, is that you? You try to write the paper without doing all the extra stuff?
No.
Don't lie to me. Every teenager tries to do that. Is that enough to say the two triangles are congruent? How'd you know that that side was congruent?
Anything.
Anything equals itself. So is that enough? Yeah. By what?
SSS.
Side, side, side. Do these seem a little easier than the proofs that we did in the past?
Yeah.
100%.
They have some kind of outline that you gotta go by, alright? You know, hey, I gotta do this, the triangles have to come at the end. The other stuff is gonna, you know, I gotta go through and prove a pair of sides, another pair of sides, another pair of sides, or a pair of sides, pair of angles, another pair of sides, so on. So you got some kind of outline to go by. How many points would that be worth on the test?
8.
How many points should you get? You should get, I'm hoping all 8. Because if you can't get anything equals itself, do me a favor. See the pause button up there?
Yeah.
Push that. Go ahead. Get that again. Page 309, find me the first 2 column proof on page 309.
Number 1.
Number 1 is? Again, when you look at number 2 and it says write a flow proof, what do you know?
Don't do it.
Don't do it, write a 2 column proof. Number 1. Number 1, they've already got the stuff all marked for you, right? They already mark everything in the picture for you?
Yeah.
Can we prove those 2 triangles are congruent?
Absolutely.
By what? What are we going to be using? What's our reason that the 2 triangles are congruent? Side, side, side. Somebody tell me the first given statement.
Segment AB is congruent to segment XY.
How do we know that?
It's given.
That's a pair of sides, right?
Yes.
So I put a little S out there. What's the next one?
Segment AC is congruent to AZ.
Okay, what is it?
Segment AC is congruent to AZ. XZ.
XZ. How do we know that?
It's given.
Notice, Michael, I put a capital G here and I put a little g here. Absolutely no reason for that, I just wanted to point that out. What goes out here beside the 2?
S.
Little s. Had you all scared that there was some reason for that, didn't I? Is that enough to say the 2 triangles are congruent? Yes, no, maybe?
No.
We need something else. What else do we know?
It's the middle line. I know there's a middle line. Segment BC is
No,
congruent to AZ.
not this time.
No, it's
Segment BC is congruent to what?
not. YZ.
Segment YZ, how do we know that?
It's given. No.
Now look, Michael, I went back to a big G. That's a pair of sides. Is that enough to say the 2 triangles are congruent?
Yes.
They've already named the triangles for us, so we don't have to match them up ourselves. I'll tell you what, let's do this. I don't like the way they matched them up. Somebody named the triangle, I don't want it named triangle ABC.
ACB.
What is it?
ACB.
ACB. If we switch it and we name it triangle ACB, A matches up to what in the other triangle?
X.
X, everybody agree with that? What's C match up to in the other triangle?
C.
C. And what's B match up to? What's our reason over here? You only got 2 choices.
That's it.
Side, side, side. Remember, if this is 2 triangles, it's got to be side, 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 or side, angle, side. Can't be anything else. That's number 1. Grab a paper towel for me. What next?
RT is congruent to US.
That was given also. That's another pair of sides, right? Is that enough?
No. TS is congruent to TS.
Segment TS is congruent to segment TS. Please make sure you're not forgetting your symbols on all these. How do we know that?
So you don't need to
No, that's if they're equal to each other. Anything equals itself. That's another pair of sides, is that enough?
Yes.
Did they already name the triangles for us?
Yes, triangle RST is congruent to triangle UTS.
UTS?
Yes.
What's our reason there?
After this test.
Remember, it's gotta be one of those two abbreviations, can't be anything else.
Let's do 24.
Is that it?
Jameson.
No, look, they're word problems.
Is that it?
But
I believe you can
want
do
to
it.
keep